number means very little, it's just distinguish. So Paul is bending this ruler, right? Consistently. Choose the letter that best completes the statement below. The aspect of the measurement that is affected is accuracy. The reason being is, right, remember we talked about a damaged measuring device affects your accuracy? That is where this is coming from. So damaged device, damaged, improper use. Would this be improper use? Maybe, but he's not actually measuring anything, so we can't speak to that. Damaged. Is the unit standard? Is the unit standard? Yes, it's either inches, centimeters, so the units is not the problem. And how you might wonder, how is precision not affected? How is precision? Because the markings in between, they stay the same, right? That doesn't change by you bending the ruler. But the accuracy will be affected. If you measure something from here to there, it's way off, right? Like this should be just measured flat, right? So accuracy is the answer there. Rick is measuring a volume in this liquid of a liquid using cylinders below. State the precision of cylinder A. We go over to A. You go from marking to marking. That's what you're wondering. So if this is your high and this is your low, subtract them, okay? So you go 200 minus 100, and then you divide that by the number of gaps. In this case, there are 2 gaps. You never count where you stand. You count as you're walking, okay? So this will be divided by 2. So this is 100 divided by 2, so it's 50. Double check that. Go up by 50s and see if you actually hit the numbers, right? 100, 150, 200, 250, 300, it does jive, right? So the precision is 50 mLs for cylinder A. Cylinder B is much easier because every marking has a number. So you just subtract, that's it. Or you can still use this formula. High minus low divided by how many gaps? Just 1 gap, right? It still works. So precision is 100 milliliters here. Justify which cylinder is more precise. Whenever you see on the exam or on a test, or justify means you have to like actually explain with a sentence, okay? So cylinder A, since it has a smaller, what goes in there, precision or increment, it doesn't matter. Because precision is the smallest increment, right, of that device. Okay, so 111, right? So I just want to go up. What's precision? Smallest increment. Uncertainty, half of the precision. Also known as the margin of error, right? The margin of error. Tolerance, the range of acceptable values. Mathematically, max minus min, right? Taking away those 2 numbers gives you the actual numerical tolerance, but the definition of it is the range of acceptable values. You love this unit, don't you? I know, I can sense it. I just feel it. Marco needs to mix water with concentrate in the garden. If too little water is added to the herbicide, it will kill all the veggies. However, if too much water is added, it will not be effective. This should kind of remind you of tolerance a little bit, okay? State the uncertainty of a measurement if Marco uses this container. It's asking for uncertainty, correct? We need precision for that, okay? So you have to find the precision. What's the precision of this thing? From marking to marking, every marking has a number. This one is easy, right? It's just going up by 2, so it's 2 liters. And the uncertainty is 2 liters divided by 2. So it's plus or minus 1 liter is your uncertainty in this case. So this is what the question is asking. So clearly indicate, I would argue if you put a U there, you are telling us that this is the answer. Okay. So you don't need to circle, but I would strongly suggest you do circle if there's a bunch of numbers. This page is worth 5. 1, 2, 3, 4, 5. Yeah. 5. Back side. Continued. Marco is still measuring. Marco needs to add 12 liters of water to the herbicide using container B. Calculate the total uncertainty of the measurements if Marco uses the container 12 times. Okay, what is that talking about? I hope this reminds you of combined uncertainty. That's what we're talking about, like things are piling up in terms of our uncertainties. So let's figure out the uncertainty of this thing. Precision of this is what? 0.2, right? Every marking has a number, so we just go by the numbers. 0.2. What's my uncertainty? Half of that. That's 0.1 of a liter. If you're using this thing 12 times, your combined uncertainty will just be 12 times this. Okay? So that is 1.2 liters is the combined uncertainty. That's why it gave you 2 marks. So whenever you have 2 marks, you know it's going to be more than just stating the answer. There's going to be some work there. By the way, this word right here, calculate, the province basically expects some work if it says calculate. You can't just come up with a 1.2 out of nowhere. You may lose marks for lack of work. Okay? So calculate, work needs to be shown. 2 marks for that. So I'll give you 1 mark for figuring out the precision and uncertainty and another mark for multiplying whatever you got. So let's say you got your uncertainty wrong. If you multiply it by 12, you still get the mark for multiplying. Okay? Next. A yard is being fenced on 3 sides. Calculate the maximum length of fencing required given the measurements and the uncertainties. So every single measurement has an uncertainty attached to it. I will do that here. Are we going to add or subtract the measurements? Add, right? I hope you understand that. So you add this up and you get 111 feet, plus or minus. If you add this up, you get 2.0 exactly feet. I give you a mark for that. If you did that, you're on the right track. But what is it asking? The maximum length. The maximum length. So we have to go 111 plus 2. And so basically, the maximum length that this could have is 113. So this is your second mark, where you actually add your 2 numbers. Because remember, if you have a measurement and its uncertainty, you could get bigger or smaller than that. Okay. How are we doing so far? Hopefully you're still there. And my last one. I'm hoping you get this one. Tolerance of a measurement. Okay. Anybody right now, even if you didn't do it, this is my olive branch here. Select one. Just random. Just quickly select one. You get 1 mark today. I'm just curious to see if you're going to get this one. It's like gambling, right? But 0 cost. 0. What's the expected value here? 0, because you don't gain anything. The tolerance of a measurement is 0.007. The nominal, which is the maximum, is this. Folks, when it's tolerance, I like this diagram right here. The maximum is 15.084 meters. The tolerance is always in here. It takes you from the highest to the lowest and vice versa. That's max, that's min. This is 0.007 of a meter. Okay? Can we figure out what this is? You just go this minus that, because we're told this is your max. Okay? So this right here, I need help. 0.77. Okay. Makes sense? So now you figured out the min as well. This diagram does it all. Okay? So we went minus that to get us that. Okay? Just minus, not -1. So anything that's in here is acceptable. Is this acceptable? 15.091, it's above here, so that's a no-go. This one, 15.078, it's just slightly bigger than the lowest. You're in here. This one is good. This one, 15.098, you're out here, not good. 15.070, you're down here. This is D, right? This would be A, and this would be C. The only one that works is B. Okay, that's the only one that would be acceptable under these circumstances. All right? So, this page is worth 2, 4, and another 1, which is 5. So this one is 5, and the front was 5 as well. So we are at 10 overall. Okay. Your name and last name there. And if you did it before you came here, and I know who you are, right?